Hello dear students, this is your Suma madam. Welcome to the next video lecture on round robin scheduling algorithm. So the round robin scheduling algorithm is designed especially for time sharing systems. So we already know that what is a time sharing systems in which a CPU time is just going to be shared among multiple processes. So that is what the time sharing system. So the RR scheduling algorithm is also similar to FCFS scheduling, but preemption is added to switch between the processes. So that is nothing but sometimes the RR can also work as FCFS, but in FCFS, depending on their arrival time, the each processes are just going to use the CPU for their burst times, isn't it? So there was no preempted, so until he finishes the job. But when we just dispatch the processes under round robin according to their FCFS, we are just going to preempt the processes depending on some condition. So that condition is fixed, or that is just going to be shown by having or by using the time quantum. So here in the RR scheduling algorithm, a small unit of time called a time quantum or time slice is defined. So wherein which the time quantum is nothing but a maximum amount of time or maximum duration for which the process can use the CPU in each of the round. So wherein FCFS, the process can use the CPU for its burst time. Say suppose P1 has 10 burst time, so it could use the CPU for 10 milliseconds. But in RR, we are just not going to allow the process to use the CPU for its burst time. Instead, we are just going to limit the CPU time or the maximum amount of time to which it could use the CPU. So that is done by defining a time quantum. So that is what the thing that is different from FCFS to RR. So the time quantum is generally vary from 10 to 100 milliseconds. So in under a RR scheduling algorithm, the ready queue will be just treated as a circular queue, and the CPU scheduler goes around the ready queue, allocating the CPU to each process for a time interval of up to one time quantum. So in the sense, say suppose there are n processes in the ready queue, so all will be just waiting for the CPU, and in one round when you just start the first round, all the processes are just going to get the CPU for only for one time quantum or one time slice. So if there are any process that could not finish the jobs in the first round, they will be preempted and put back in the put back at the tail of the ready queue, so that they could just use the CPU in the next round. Even in the next round, the same amount of time or the same time quantum will be defined, and it could use the CPU only for that amount of time. So this continues until all the processes finishes the job in multiple rounds. So there might be two cases that would arise. The one is that the CPU may have a CPU burst time that is lesser than the one time quantum. So that is nothing but, say suppose there is a process P1 who can have a 5 milliseconds of time, and I have just defined the time quantum as 10 millisecond. So in that case, so the CPU burst time is 5 and time quantum is 10 milliseconds. So means the process could just finish the job within the time limit. The maximum amount of CPU time we have told to use is 10 millisecond, but since it is required only 5 milliseconds, so it could finish the job within the time limit. In that case, the process itself is just going to release the CPU voluntarily. We are not going to force by causing the interrupt. The CPU will be released voluntarily. So then the scheduler will then proceed to the next process in the ready queue. So otherwise, there is a second case in which the CPU burst time of currently running process, which is longer than the one time quantum. Say suppose that vice versa example, in which the 5 milliseconds would be the burst time, and we have only 2 milliseconds of time quantum. So in this case, the burst time is larger than the time quantum. So in which the process could not just finish in a time limit. So in that case, we have to forcefully preempt. I mean, we need to forcefully stop the execution of the current process. We need to preempt the CPU to the next process, and this awfully done process will put back in the ready queue, so that it is just going to get the CPU in the next round for the time quantum what we have specified. So these two are the cases we need to just remember under RRQ, RR scheduling.